Good evening, everyone. So my name is Aditya Sharma, and this is a Power Plant System Engineering course being conducted by IIT Guwahati Department of Mechanical Engineering under the NPTEL program. And we are into the sixth live tutorials session of this course. And in the series of last couple of these tutorials, we have been going through the vapor power system, right? So where we initially saw the uh, cycles, thermodynamic cycles related to a vapor power system, right? And then later we moved on to the rotodynamic machines linked to vapor power system like turbines, right? Impulse turbine, reaction turbine, all that we have gone through. And in the last week's content, we discussed nozzles. And now in this week's content, we have boilers to discuss. Okay. So instructor for the course is Professor Niranjan Sahu from Department of Mechanical Engineering, IIT Guwahati. And I'm a research scholar here at Department of Mechanical Engineering, IIT Guwahati only. So we shall wait for another couple of minutes. After that, we shall start today's session. Okay, so I believe I can start with today's session. So as I was telling earlier that today we will be discussing steam generators, boilers. Okay. So in total, there are three lectures in this week's content. First lecture is a basic discussion and introduction to the steam generators, and then the remaining two lectures are on water tube boilers. Okay, so different components of water tube boilers have been discussed. So we shall start from lecture number 13, that is steam generator. Okay, and the session will go on as we have been doing in previous sessions, in the same way. One lecture and then questions related, and then another lecture and questions related to that lecture. So this way we shall move forward, move ahead in our session. So let's see the topics of lecture 13. So first topic here is your steam generator. So steam generator basically has different components. So we have economizer, then we have a boiler, then we have a superheater, then we have a reheater, then we have a air preheater. Okay, we can take steam drum and boiler also. So first is economizer, where what we do is when we are feeding the water into the boiler. So before feeding it, we just heat it by means of the flue gases, right? The flue gases that are exiting from your superheater, right, or your reheater. So the flue gases have done their work. Now they are at some low temperature, but still we won't waste that energy of flue gases. And what we do, we use it to heat our feed water, right? So that is your economizer, right? Then is your steam drum, where the vaporization takes place, right? Initially the vaporization takes place. Okay, then is your superheater. So we have discussed superheater, that how it heats the steam, right, and then removes the moisture content of the steam, right? And then is your reheater. So from the high pressure turbines, when the steam exits, it is again reheated, right, and then expanded. So reheater also we have discussed previously. Then there is one more component, that is air preheater. So what happens is that the in your furnace, right, in your furnace, so you have your fuel and you have air. So this air that is needed for combustion, so we preheat it again with the flue gases, right? So the flue gases that would have been exhausted, right? So we are using those flue gases that are at low temperatures, right, to heat this air. So what it does is it increases your adiabatic flame temperature, right? That is your uh, air preheater. So I have briefly given you the gist of all the components, but we will in detail these have been discussed later. All right. So this is your sorry. So this is your steam generator. Then is your fossil fuel steam generator. So in your fossil fuel steam generator, okay, two boilers have been mentioned. So one is your fire tube boiler, then is your fluidized bed boiler. So what happens in your fire tube boilers is that your hot flue gases, right, that are combusted, so they flew through some tubes, right? And these tubes are surrounded by water. So how these tubes are surrounded by water? So we have some shell where we have these tubes. So flue gases pass through these tubes, and in the surrounding we have water. And this way, the heat transfer between the flue gases and the water takes place, right, for the generation of steam. Right. So this is fire tube boiler. Then is your fluidized bed boiler. So in this fluidized bed boiler, your air flows upward from some air plenum, right? Some space where we have air. So this moves upwards into a bed, right? Bed again is a space where we have coal, right, for combustion. So here the combustion will take place in this space. This space we are calling as bed, right? And here where the combustion is taking place of coal, here we have our further we have our tubes in which we have water, right? So the heat transfer takes place this way in your fluidized bed boiler, right? So these are two boilers. Then is your next type of boiler, that is your water tube boiler, right? So this is the major type of boiler around which the discussion revolves in the coming two lectures. Before that, I just skipped one thing. So in your steam generators, right? Yes. So there are these steam generators have been categorized into uh, subcritical and supercritical types, right? Based on the pressures at which they function. So if your pressure is less than your critical pressure, that is 220 for water, in that case it will be called subcritical, right? So subcritical is also another name of your water tube drum type boiler, right? And your supercritical is your once through type of boiler, right? So these are two categories. Okay. So here we are discussing water tube boiler. So I'll just write down the components. So we have a draft fan, So your working fluid moves like this, or your water moves like this, right? So we have some forced draft fan, right, through which uh, your water moves to economizer, right, where heat exchange takes place between your flue gases and your water, right? Then from here it is water is fed to your steam drum where vaporization takes place, right? So in your steam drum, you have a downcomer and a riser. So we shall see it later. So how that, what is the role of a downcomer and what is the role of a riser? Then after that, we have superheater, right? After that, we have a reheater. And then after that, we have induced draft fan from where your, yes, from where your steam further moves forward, right? So after this water tube boiler, components of water tube boiler. So steam drum has been discussed, right? So your induced draft fan also can handle the hot air, right? While your forced draft fan can only handle cold air. Okay. So this is your steam drum. So I'll just draw one steam drum where a natural circulation takes place. So here heat from fossil fuels, right? So here you have water. Okay. So this is your downcomer. This is your riser. This has some height h. Natural circulation. So forced circulation is also one option. Okay. So what happens here is this is your steam drum. So we have water here, right? So this water will move downwards in your downcomer, right? Here, this in your riser, your water is partially heated, right? And then which eventually gives rise to vapors, right? And this again moves to your water with some vapors again moves to this steam drum, right? Here, this vapor is extracted from your water, right? And then this vapor from here stream drum is further given to your superheater. Okay, from superheater it goes to your high pressure turbines, right? And then from high pressure turbines to your reheater, then to your low pressure turbines, right? Then to your condenser, right? So this is your natural circulation in your steam drum. So I hope downcomer and riser is clear, right? Also, the densities in your downcomer and riser are different. So downcomer has high density, obviously, right? Because it's mostly in liquid state, but riser has low density, right? So this pressure difference in the downcomer column and the riser column, this also this only gives rise to the circulation in this type of natural circulation. Okay, all right. So this is your steam drum. All right. Okay. So this is your steam drum, and your if you talk about water circulation, so it takes place in water tube type of boilers. But if you see your once through type of boilers that are used for your supercritical conditions, right? For your pressure, when your pressure is greater than critical pressure, in that case, we do not need a separator, right? We do not need a separator that separates your water from your vapor, because there are no intermediate stages, right? So there is no bubbling in that case. All right. So in that case, so if you see your once through type of boiler, here no steam drum is required. Okay, is required, right? So in that case, no water circulation is required. All right. So this is your water circulation in boilers. Okay. So now we shall see questions. So the circulation for water tube type of boilers I have discussed in 13.4.1. In 13.5, I have just discussed where your water circulation is not required, in which case. Okay. Okay. All right. So this question asks here that which of the following is not a part of steam generator. So four options have been given. One is your economizer, then is your air preheater, then is your nozzle, and then is your reheater. So if you see, economizer is used right, is kind of feeding to the boiler. So that this is a part. Air preheater is where you preheat your air through flue gases, then it goes to your furnace, right? Then is your nozzle. So we have seen in our previous lecture that nozzles are linked to your turbines, right? And then fourth is your reheater, right? So reheater again is a part of your steam generator, right? So we have seen here, right? Reheater is a part of your steam generator. But then out of the four options, if we have to choose, so the weak one out of these four, I believe, is nozzles, right? Right? Because directly it's not a part of a steam generator, right? Okay. So after that, moving on to next question. So I'm discussing questions based on your lecture 13. So this is question number 2. So it says that which type of steam generators operate above your critical pressure. So we have four options here. So you can have a look and try to answer. So the question asks about steam generators and they are working above your critical pressure. So one is your A option is your water tube drum type. B option is your subcritical. Then is your once through. Then is your no option is correct out of the given options, right? So I had told that there are two categories. One is your subcritical, one is your supercritical. So subcritical is that is less than this. Supercritical is this. Okay. Now your subcritical is also your water tube type boiler. And your supercritical is once through. So why once through? Because there is no no circulation here, right? So in your water tube type of boiler, the circulation takes place in your steam drum. But here, because there is no partial vaporization, right? So in that case, uh, no steam drum is required and no circulation is required. That is why we are calling it once through. Okay, so that is your supercritical. So if you see the question and the options, so options C comes out to be the correct option. Okay, so this was your question number 2. I hope there is no doubt in this question. So we will move on to the next question. So please read this question and try to answer. So you can give your answers in the comment box also. So the here question, so the question here says that in fire to tube boilers, the hot flue gases flow through the tubes surrounded by water in a shell. So whether this is a correct statement or not. So this is, I believe, a correct statement. Okay, because in your hot this fire tube boilers, your flue gas passes through your tubes and then you have water in a shell. But if you see your water tube boilers, the case is opposite, right? You have water flowing in tubes and then your hot flue gases are surrounding it. Okay, so this is a correct statement. Question number 3. Okay, this was on fire tube boilers. So these fire tube boilers are the early versions of boilers. So now we have this question. So you must read this question and try to answer. So which of the following is true about a steam drum? So we know what a steam drum is, right? So you have your steam drum where your water enters from your eco economizer, right? Sorry for my pronunciation. And then in your steam drum, you have a downcomer section and a riser section. Downcomer section is that in which your water moves downward in a space where your water is heated to get vapors, right? And these vapors through riser again enter into your steam drum, right? The vapor from your water are separated in steam drum, right? So this is your steam drum. Now if we read the statements, so it says that only steam is present in it. First is this statement. Then is steam is separated from boiling water in it. Then third is the density of saturated water in your downcomers is greater than the average density of two-phase mixture in the riser. So riser has your water also and vapors also. Okay, that is why two-phase. And in your downcomer you have saturated water only. Okay. So if you see the options, it says that first option says that only one is correct. So one is only steam is present in it. So whether this is correct or not. Second option is 1 and 2 only are correct. And third is incorrect. This means third option is only 2 is correct. So steam is separated from boiling water in it. So 2 we know is correct. Okay. Then D says that 2 and 3 only are correct and 1 is incorrect. It says that. So if you see your first statement, only steam is present in a steam drum, that is not correct. Okay. Because that contradicts your second statement that steam is separated from boiling water in it. Okay. Then third statement is correct. That is about density. So it boils down to only statement number one is incorrect. Okay. So now if we see the options, so D options comes out to be correct. Okay. 2 and 3 only are the correct options. Okay. So this is your question number 4. So now we shall move ahead to question number 5. So please read this and try to give a correct correct option for this question. So question number 5, 5 is your void fraction is defined as the ratio of dash of the dash to the dash of the steam water mixture. So 4 options have been. So what is your void fraction? It is somewhat similar as dryness fraction. Okay. So the only difference is that in your dryness fraction, we consider mass ratios, and in our void fraction, we consider volume ratios. Okay. So void fraction is defined as the ratio of volume of the vapor to the volume of the steam water mixture. Okay. So mass is not correct, and water also in the second fill in the blank is not correct. So it's the ratio of volume of vapor to the volume of steam water mixture, right? Dryness fraction is mass of your vapor to the mass of your steam or water mixture, right? Mass of vapor in your steam water mixture to the whole mass of your mixture. So option C is correct for question number 5. Then we will move on to next question. Question number 6. So which of the following is not used in a once through boiler? I have discussed it 2 or 3 times in this session only. So once through boiler, if you want to draw once through boilers, it is like this. The TS diagram. Though we have seen it in one of the previous sessions. I believe it was session number 3 where we have discussed the modified Rankine cycle. So what happens is from here it is something like this. Okay. So TS diagram is something like this. One case is where you move like this. Okay. And one case is where there is no intermediate state, right? So this is your once through type of boiler. Okay. So I've not drawn it properly, but I hope you understood what I'm trying to say. Okay. All right. So now moving on to next. Okay. So in your once through boilers, economizer is there present, superheater is present, okay, furnace is present, but if you see steam drum, it is absent, no circulation, right? So steam drum is not used in a once through boiler, okay. B option is correct for question number 6. All right, then moving on to next question. So this is a numerical type of question. Please have a look at the question first, then we shall solve it. Okay, so let's solve this. So this is question number 7, and it says that a steam drum is operated by a downcomer riser system. Okay. The density of water in downcomer has been given this, and average density of your mixture in the riser is 284 kg per meter cube. And the downcomer riser system's height is 8.2 meters. Okay, which is receiving a uniform heat and saturated water from your economizer. Okay. Then you have to find the driving pressure for the system. So the circulation that is taking place, water circulation that is taking place in this steam drum, for that, what is the driving pressure? Gravity is acceleration due to gravity. Its acceleration has been given as 10 meters per second square. Okay. So this is question number 7. Rho downcomer equals to 486 kg per meter cube, right? Then rho Fg is 284 kg per meter cube. Okay. or FG, or you can write riser also, R. Okay. Then height has been given as 8.2 meters. So I hope this is clear that we are talking about this case, right? About this figure. Okay. Then three things have been given. Fourth is this. Acceleration due to gravity has been given as this. Now, the driving pressure. Driving pressure is what? So this is pressure due to column. This your downcomer column. Density GH minus the pressure due to your riser column. Okay. This is riser GH. This is rho DC minus rho R GH. So putting the values in the above expression, this gives us 10 into 8.2. So now if we solve this, so this is 202 into 10 into 8.2. So this is 16,564 pascals. That is 16.564 kilopascals. Okay. So this is your answer to this question. So this was your question number. Okay. So I forgot to write answer here. So it will be 16.564 kilopascals. Right. So this is your question number 7. I hope there is no doubt in this question. If there is, you can just write in the comment box and I shall answer. So moving further, now we have lecture number 14. that is based on water tube boilers. So different parts of water tube boilers or boiler I have already mentioned. Okay, so we have economizer, steam drum, superheater, reheater. Okay, so this is from your previous lecture only. Then is your superheater here. So lecture number 14, superheater. So this is your superheater. This is your reheater. So here we are discussing superheater. Okay. So this superheater, so there are types of superheaters. Okay. There are three types based on how the energy is transferred to the steam. Okay. How the heat transfer takes place. Based on that, we have types. So first is your convective superheater. So as the name suggests, through means of convection. Okay. Through means of convection, the heating takes place. Okay. Then is your radiant superheater. So by means of radiation here, the heating takes place, right? So all this is this heat transfer is related to flue gases only, right? And combustion that is taking place in the fuel by means of fuel and air, right? In the furnace. Okay. And there is another type of superheater, that is your pendant superheater. Okay. So this is a combination of your convective superheater and your radiant superheater. Okay. So both the superheaters are used in this type of superheater. Okay. Then one important difference between convective and radiant superheater is, so I'll draw this and then I'll explain. So the difference in your radiant and convective is that as we increase the load, okay, as we increase the load in case of your convective superheater, you can see that your outlet temperature of steam increases, right? So how this happens? So when we are increasing the mass flow rate of steam, right, that is entering the superheater. So with this, we increase the flue gases, right? The flow of flue gases that are causing this superheating effect. So we increase that, right? And eventually, what happens is that your heat transfer rate increases. But if you see your radiant type of superheating, in that case, with the increase in your load, right? That is when the steam flow increases in this type of superheater, then the heat transfer rate decreases, right? And then the pendant type is such that we uh, want our superheater to be independent of the load, right? We want the temperature to be independent of the load that is being given to the superheater. So in that case, we use this pendant type of superheating. Okay, so this is basically the difference between these three types of superheaters, right? So I have discussed these. Okay, then is your attemperation. So what is attemperation? So sometimes what happens is that we are heating our steam in superheater, and then the heat of the steam exceeds the design temperature, right? The temperature for which we have designed our whole system, right? So it this temperature tries to exceed that limit. In that case, what we need to do is we need to cool this steam down, right? We need to lower the temperature, right? So that the temperature remains in limits. So for that case, we use attemperation, right? So attemperation is of majorly two types. So first is your surface a temperature. So what happens is here the heat, extra heat that is extracted from the steam is by means of majorly convection, first of all. And then how do we do this? So we take some portion of steam from the exit of the steam, your steam superheater, right? And we pass this steam through some tube, right? So this tube is contained in some shell that is having water, right? So this extra heat is transferred to this water, and this way we lower down the temperature of our steam. Okay, so this is the surface temperature. Then is your direct or spray temperature, where what we do, so we spray water here. Okay, so we here spray water with this steam, high temperature steam, and this way we try to cool it down. So this type also is considered very rapid and sensitive means of temperature control. Okay, this type is considered as very rapid and sensitive type of temperature control of the steam that is exiting the superheater. Okay, so this is your temperation. Okay, so after this, then we will move on to questions related to lecture number 24. But before that, we shall take a short break of 5 minutes, and after that, we shall continue with the session. Okay, so let's continue with the session. So we have now question number 8 to answer. So few statements have been given and then options have been provided. So the question asks about superheaters. Which of the following is true about a superheater? So please read this. First statement says that it is used to reduce the moisture content of the steam water mixture. So this is first statement. It is used to reduce the moisture content of steam water mixture. It is used to increase the steam temperature. It is used to heat the air that enters the furnace and thus increase the adiabatic flame temperature. So first option is only first option is correct. It is used to reduce the moisture. Second says that it is used to increase the steam temperature. 1 and 2 only. Second option says that both these are correct. C option says that only third is correct. So we know that third is not correct, okay? Because the third statement that has been made is for your air preheater, okay? This is for your air preheater and not for your superheater, okay? Now we have seen in our discussion uh, on superheaters, right? When we were discussing modified Rankine cycle, that we don't want moisture in our steam that enters the turbine because that can be harmful to your turbines, right? So in that case, we want to remove this moisture, and that we do by further heating the steam, right? To so that there is no moisture in this steam, and this we did by superheating, right? So in that case, first option comes out to be a correct statement, right? And then second option is also correct, right? We superheat the steam by means of superheater, and which eventually increases its temperature, right? So in that case, B option comes out to be true, right? So B option is correct option. So this was question number 8. Moving on to next question. That is question number 9. So it's a true or false type of question. So please have a look at the question and try to answer. In a radiant superheater, an increase in steam flow due to increased load demand results in increased exit steam temperature. Increase in steam flow due to increased load demand leads to increased exit steam temperature. So we can solve this using this diagram. Okay, this graph. So for your radiant type of superheaters, you have seen that with increase in your steam flow, the heat transfer rate decreases. Okay. But the statement says that and heat transfer rate decreases and thus the outlet temperature also decreases. Okay. But here if you see, the statement says that the exit steam temperature increases. So that is opposite to what the reality is. In that case, this is a false statement. Then moving on to next set of questions. So we have 3 questions based on this information that is given. So we have been given a graph and then the related enthalpies also have been given. So 1 to 2 is your economizer. This is your 2 to 3 is your boiler. 3 to 4 is your superheater. Then 5 to 6 is your reheater. Okay. Then so let's first write these down. Question number 10 to 12. So what has been given? H1 is given as 184 kilojoules per kg. H2 is given as 1311 kilojoules per kg. H3 is given as 2760 kilojoules per kg. H4 is given as 3489 kilojoules per kg. H5 is given as 2706 kilojoules per kg. And H6 is given as 3279 kilojoules per kg. So this has been given. So what we can do, we can find out for economizer. We can find out how this. So if you work this out, this will be then for your boiler from 2 to 3. This. Then for your superheater SH, that is from 3 to 4. Then your reheater from 5 to 6 is this. Okay, now let's see the questions. So find the heat load in the economizer. So now question number 10, solution. Heat load HL for economizer. Okay. Is Q economizer by Q total? Now, what is Q total? Q total is H4 minus H1 plus H6 minus H5. Now, if you see your H4 is 3489 minus H1 is 184 plus your H6 is, so H6 minus H5 we have already found out, that is 573. Sorry. So now if we calculate this, 3305 plus 573. So this is 3878 kilojoules per kg. So this is your Q total. So heat load for your economizer is, so Q economizer is 1127. Q total is 3878. And now if you calculate this, so this comes out to be, that is 29.06%. Now, okay. Now the next question, which says that find the heat load in the boiler. So heat load in the boiler, question number 11. Is Q in the boiler divided by Q total. Q for boiler is 1449. Q total is 3878. So now if you solve this, So this is 37.36%. Okay, this is your question number 11. Now the next question. Which says that find the ratio of heat load in the economizer to the heat load in the boiler. So now taking the ratios from question number 10 and 11. So solution. The ratio is HL economizer, HL boiler. 2906 divided by, so yes. So this comes out to be 0.7778. So in terms of percentage, if the question asks, this is 77.78%. Okay, so this is your question number 12. Now we have lecture number 15. That is the second part of your water tube boilers. Water tube boilers that are also known as subcritical boilers, used for pressures less than your critical pressure of water. So this pressure is the pressure of your at which the boiling takes place, right? So this is your, yes. So this is your this pressure. Okay, here 8 to 1. So this is your this pressure. I hope you remember in the Rankine cycle we have discussed it. In the session related to Rankine cycle we have discussed it. Okay. Okay, then water tube boiler. We have water tube boiler. So this is the introduction and parts related to water tube boilers that we have already discussed, right? Economizer, your steam drum, right? Superheater, reheater, then exit. So your reheaters. So your reheaters are somewhat similar to your. So your reheaters are somewhat similar to your superheaters, right? Here also the major heat transfer mode is convection. Okay. Right. Then is your economizer. So I have been telling this. So the flue gases that exit your superheater or reheater that are again circulated through your feed water, right? And the remaining heat that it has is given to your feed water, and this feed water then again is given to your steam drum, right? So what this heat from the remaining heat from the flue gases does is it takes your water to your saturated liquid level, right? And from there, boiler is used, right? So here also heat transfer mode again is major heat transfer mode is what? Convection. Okay. Then is your air preheater. So there is majorly two type of preheating. Okay. One is your recuperative. Okay. Where heat exchange takes place from surface. Okay. So tube and shell type of arrangement where in tube we have one thing and in shell we have one thing, and the surfaces, the heat transfer takes place between your air and your flue gases through surfaces. Okay. So this is that type of preheater. Then is your regenerative preheater. So here we take help of energy storage devices. So we store the energy in some energy storage device, and then this device is used to preheat the air. So devices like corrugated steel, okay, then your ceramic matrix. So this is your regenerative type of air preheating. All right. So what it does, so what the air preheating does, it increases your adiabatic flame temperature. So I don't know whether you are aware of this adiabatic flame temperature concept. So basically, this means that if we are uh, combusting something, right, in adiabatic conditions, so the maximum temperature that the flame attains, okay, in combustion. So that is adiabatic flame temperature. So eventually, what this does is this increases the your whole combustion process, okay, and which proves to be efficient for the whole system, the system as a whole, okay. So this is basically the function of your air preheater. Right. After that, we have fans. So fans. So there is forced draft fan that takes cold air only. Okay. Then is your induced draft fan. It can handle hot air also. All right. So this forced draft fan is majorly used at entrance, and your induced draft fan is used at exit, right? So your induced draft fan is later connected to your stack, right? So stack is basically from where all your combustion products or flue gases exit to the atmosphere, right? Then your fans can be centrifugal type and they can be axial type. Okay. So this is your fans. Then blading also has been discussed. What type of blading is used in centrifugal? What type of blading is used in axial type of fan? So this you can refer to lecture number 15, right? So this has been discussed there. Then is your stack. So stack is your chimney type of structure, right? Like this. So from here, your flue gases are exiting. So this is your stack height, and this is your plume, right? So between A and B, what you see is your plume, right? But then to have a value for plume rise, so we extend this AC and BD towards a conversion point, right? And then we take its height from the maximum height of your stack. Okay. So this is your stack, right? Okay. So now let's see questions based on it. So I believe this is the only question that I have from this lecture, and this will be the last question for the session. So please have a look at the question and try to answer. Two statements have been given. So the question is on economizer. So the first statement is an economizer uses the flue gases to heat the feed water to saturation temperature. So this is whether this is correct or not. Then second statement is primary mode of heat transfer in an economizer is convection. So whether this is correct or not. So we have seen that first of all, second statement is correct, right? And then first statement says that an economizer uses flue gases to heat your feed water to saturation temperature. So from, if you see this graph, so from 7 to 8, right? 8 is your saturation temperature, right? Where your liquid water is in saturated liquid state, right? So economizer uses flue gases to heat the feed water to saturation temperature. So this is also correct. Okay. So now let's see the question options, what the options say. So both 1 and 2 are true, and 1 is the correct explanation of 2. So in terms of explanation, we need to tell that whether there is a linkage between statement number 1 and statement number 2. So both 1 and 2 are true, but 2 is the and true is 2 is the correct explanation. So this first and second option say that A and B option say that 1 and 2 both are true. Okay, that is correct. And it says that 1 is the correct explanation of 2. So whether this is the case or 2 is the correct explanation of 1. Third option says that both 1 and 2 are true, but 1 is not the correct explanation for 2, right? Or B says that both 1 and 2 are false. So if you see the four options, you'll see that though both the statements 1 and 2 are correct, but there is no linkage between two statements in terms of 1 is explaining 2 or 2 is explaining 1. Okay. So in that case, the correct option comes out to be C, right? Because 1 is not an explanation for 2, right? So this is the best option that we have out of these four, right? The fourth says that both are false. That is not correct. Okay. So correct answer to this question is C, right? Okay. All right then. So this was it about this session number 6. So this was on again vapor power system part 3. So in first part, so I'll conclude the session. So in first part, we saw Rankine cycle and modified Rankine cycle. Then I believe in second part, we moved on to turbines and nozzles. Now in this third part of our vapor power system, we initiated with steam generators, right? So basically there are majorly two types. One is subcritical type, and second is your supercritical type. So in our this week's content, we discussed subcritical type of boilers and its different components, right? Be it economizer, superheater, reheater, air preheater, right? So all this we discussed, and this way we have performed this session. We have completed this session. So next session again will be on next Tuesday with the same timing, that is 6 to 8 p.m. All right. So hope to see you guys in that session. Till then, bye and thank you for watching this session.